Thank you for coming to our presentation. So a little bit about Clicker and myself. Clicker is a Silicon Valley technology company that provides a platform called Cloud Center. Think of Cloud Center as a solution for large enterprises that can use it to easily model, migrate, and manage a variety of application workloads on private data centers or public clouds. So what we thought we would do as a very interesting exercise today is our customers, our users, use us for a variety of use cases. But the one that we're going to pick up today is migrating an application from a public cloud, Amazon, and moving that at the click of a button to a private cloud environment. The private cloud that we have chosen for this demo is OpenStack. OpenStack powered by Cisco Cloud Services. So this is a private cloud running on-premise behind the data center. So that's the demo we're going to do. I'm going to first start the demo, kick it off. The migration does take some amount of time. And then we're going to peel the onions. We're going to discuss how the technology, how Clicker works behind the scenes. So let me dive into the Clicker product straight away. So this is the Clicker UI. This is Cloud Center. Cloud Center is available as a SaaS offering, software as a service, but we also provide it as an on-premise installation. So here we have set up a demo account, and I'm going to log in as the administrator. So as we are logging in here, you will see the Clicker dashboard come up. On the right-hand side, you will see a host of different cloud offerings that Clicker is managing. A variety of public clouds like Amazon, Azure, IBM Software, so on and so on, as well as private cloud environments. The private cloud that we are interested in for this demo is OpenStack powered by Cisco. On this dashboard, you will see a bunch of other information as well around your activity, how many virtual machines are you currently running, as well as historical usage over time. In this demo account, we also have onboarded or migrated a variety of applications. The application that we are going to use for this demo is Confluence. In fact, this is an application that we are using at Clicker Technologies to run our website. Our website is based on Confluence. So let me quickly look at this application. This is the application. I can also rapidly review the application topology. For the purposes of this demo, we have chosen a simple two-tier application, but the same concepts apply to more complicated multi-tier, multi-component applications as well. So as you can see in Clicker's graphical designer, this is a two-tier topology that's got the application server, Tomcat, and it's also got the database, which is based on MySQL. So to just show you how this works, and to kick off the migration, I'm going to go to the Deployments tab inside Clicker. And we have an existing deployment of this Confluence application, which is currently running on Amazon Web Services. So let's dive into this deployment and see how it looks. This is the actual two-tier application. It's up and running, and it's up and running on Amazon US West, Oregon. I can access my application from here. And this is the Confluence application. So what I'm going to do is this is all a live demo. I'm going to create a new space inside my Confluence website. Let's call it Cisco Live, obvious name. Let's go ahead and create the space inside Confluence. As you can see, we have created a new space inside the Confluence web application inside the website. So now the next thing that I'm going to do is I'm going to go back to the Deployments tab. I'm going to pick this Confluence deployment, and the goal is to one-click migrate this from Amazon to OpenStack internal. I'm going to kick off the migration now, and then I'm going to dive into the Clicker technology around what's happening behind the scenes and how we are doing it. So let's call this Cisco. And as you can see, we have already made a selection for our cloud. This is OpenStack. We have made selections around the different tiers, what kind of networking, what kind of storage, and instance types we're going to use on that OpenStack environment. And then I'm going to go click Submit. This is starting a migration of a two-tier application from Amazon to OpenStack. What we're going to do behind the scenes now is, as you can see, there is this migrating status. we're going to take the existing deployment on Amazon, shut it down, back up the data in the process, move the data, move the application components to the internal private cloud, and then on that cloud, bring up the entire application topology in a single click, restoring the application with the data. So towards the end of my demo, I'll return back to our to the migration, and we'll see the migrated application. So that's really what Clicker is about. Clicker is about taking a variety of application workloads and managing them across multiple clouds. So while this is going on, let me go back to my slides and talk a little bit more about the product and the technology itself. So as we mentioned, Clicker is an application-defined cloud management platform. Today, a variety of companies are looking to run multitudes of applications on different cloud environments ranging from public to private clouds. Today, every cloud is very different and comes with its own unique set of APIs, services, and best practices. So if you go to an Amazon as an example, Amazon has its own EC2, networking, storage, EBS APIs, different ways to manage virtual machines, different ways to manage users and credentials. But if you go to OpenStack, OpenStack has a different set of concepts, Nova, Neutron, Cinder, to manage the infrastructure on OpenStack. On the other hand, if you go to a very different environment like VMware, VMware vCenter, vCloud Director, will have a different set of APIs to manage the compute, storage, and networking elements. That makes cloud very complicated, very infrastructure-centric. And to get an application up and running on a cloud, whether it be a new application or an existing application, the user today has to understand the cloud environment. You have to dive in and create scripts, could be in Puppet, could be in Chef, or could be workflows that are going to call the cloud APIs to provision the right compute, the right storage, the right networking, and deploy the application on top of it. That tends to be a very difficult exercise. So Clicker takes that complexity away. We provide this central management platform and provide a simple application-centric view to our users. Users can come in and create what we call application profiles. Think of profiles as blueprints or templates where you can rapidly describe your application workloads. So in the example that I took, the Conflicts example, the blueprint had a two-tier topology. It had a MySQL database and a Tomcat server. That's the Confluence application profile. In the profile, the user can provide further information about their application. Is there any data that needs to be migrated? Are there any particular infrastructure requirements for every tier around compute, memory, storage, so and so on? All that goes into a central application profile. The Clicker engine takes that profile to automate the application's entire lifecycle on underlying clouds, starting from the deployment of the application, ongoing management, as well as implementing complete governance around your workloads. Very importantly, these application profiles are cloud agnostic. All the user needs to do in creating these templates is knowledge about the application. But the user is not required to create any hard-specific, hardwired scripts onto any particular cloud provider. Beyond that, the platform provides complete migrate, manage, and governance abilities for those applications. So the scenario that we just kicked off in the demo was basically an application running on a public cloud, Amazon, that is now in the process of moving to a private cloud, OpenStack. Today, Clicker Cloud Center supports the most common private and public clouds. Our public cloud support ranges from the commonly used clouds like Amazon, Azure, IBM Software, NTT Clouds, as well as the most common private clouds around VMware, vCenter, and OpenStack. So let's dive into this a little bit more. What's going on is if somebody had to run a 3-tier, N-tier application on a particular cloud environment, today, without Clicker, the process would be to create a workflow or a script that's going to automate the entire application deployment in a particular cloud. For example, if you have a 3-tier application, inside the script, you will have to call the cloud infrastructure APIs to launch the right virtual machines. For example, if you're on Amazon, you'll have to call into the EC2 layer to spin up your VMs. For the right VM, you'll have to attach it to the storage. So for the database tier, you'll have to mount it to persistent storage like EBS. Between the different tiers, you might have certain firewall rules or network ACLs that need to be set up. Depending on the cloud you're on, the way you configure that is going to be different. On Amazon, that's done through security groups. But if you're on a private cloud environment like OpenStack, you might have to call into Neutron APIs to configure the same rules. The user will have to have all that knowledge and manually write such a script. In that script, you'll also have to call out to the installation for your database, for your app server, for your load balancer. For each tier, you'll have to load up the application artifacts, be it data setup or be it your application packages such as WAR files or EAR files. All of that has to be managed by a very complicated, lengthy script. If you create this script for an OpenStack environment or for, say, an Amazon environment, that script is hardwired, locked into that particular cloud. On the other hand, in Clickr, you don't have to do any of that. In Clickr, you have a very simple browser-based graphical designer. The graphical designer comes with a service palette. Clickr provides a variety of out-of-box service palettes, common software load balancers, application servers, databases, but this is an extensible palette. So if you have your own components, you can always model them and add them to this palette. All the user has to do is drag and drop the components that make up their application. So in the WordPress example that I was just showing, you have an Nginx load balancer, an Apache HTTP server, and a MySQL database. For each of the tiers, the user can provide us more information on the right-hand side. So there's a properties palette. For example, in the web server tier, the user can provide detailed information about how much memory, how much compute, what kind of requirements does that tier have in terms of infrastructure. You can also model the firewall rules, the connectivity rules between the different tiers. For any particular component, like the web server showed here, you can provide the web server specific properties as well. So for example, what's the application package that needs to be installed in order to bring up your application. All that information is provided on the right-hand side. If the application tier needs to run as a cluster, you can also model it as a cluster and provide the number of nodes to be launched in that cluster. If your application can auto-scale, you can also provide the min number of nodes or the max number of nodes inside that cluster. So this is a very simple topological modeling of the application. This model can get as complicated as you would like. So if you need to drag and drop Docker containers, virtual machine images, maybe existing applications that are already deployed and you want to model them as an endpoint service in this topology, you can do that and create fairly complex enterprise-grade application models here. Once this topology is created, this is available inside the application catalog in Clickr. And from here, the user can do a variety of functions, take a variety of actions on those applications. You can also share on applications. You can share them with other users. Maybe you're going through a development workflow where there are developer users and different ops users. You can collaborate on the CI/CD process from this catalog as well. From here, you can choose to deploy applications. You can choose to migrate them from one environment to the other, etc. A very interesting aspect about this is going back to my graphical model. The model itself is cloud agnostic. So there's nowhere inside the model that the user has provided us information on a particular cloud like Amazon or OpenStack. The user can run that application on any cloud supported by Clickr. One of the benefits of that is benchmarking. So if you set up your application with a test workload, you can go ahead and benchmark it on multiple clouds. These could be public clouds like AWS and Azure, or could be your own private cloud environments. In those environments, you can try out different configurations, such as virtual machine instance types. What Clickr will do is we'll go ahead and run a benchmark. We will run that test workload on all of those configurations simultaneously. The only reason we are able to do that is because those profiles and our orchestrator is cloud agnostic. We'll actually measure the cost of running those workloads, the actual performance, and tell the user where that application is getting the best price, the best performance, or the best trade-off between price and performance. And based on that, you can make insightful choices, insightful decisions around where to run the application. You can do that manually, or you can even set up policies to automatically send the workload to the right optimal execution engine, the right cloud. So the migration scenario that I showed you could be completely automated, where if there's a change in your benchmark data, you could automate the migration from one cloud to another environment, making sure that your application is running optimally. So that was just a little bit about the Clickr product. Let's dive into the technology itself, what's the architecture, and how this works behind the scenes. So Cloud Center is a distributed architecture, and it is composed of two key elements, a central manager and a cloud resident orchestrator. So the UI that you saw is our manager UI, the browser-based interface. This manager is available both as a SaaS from Clicker, but also can be installed on-premise using a virtual appliance that we provide. Uh, all the Clicker functions, ranging from our migration, management, governance, are accessed through the manager. From a development perspective, from a developer's perspective, not only do we have a UI, but very strong northbound REST API. So if you want to integrate the manager with, for example, on-premise CI/CD, your build process, as an example, Jenkins, or maybe you have your own on-premise automation, then you can integrate the manager into that through our REST APIs. The other piece is the orchestrator. So this is a virtual machine running on every data center or cloud that is under Clicker's management. So as an example, if you have multiple OpenStack data centers, private data centers based on other technologies like vCenter or public clouds, you will have one orchestrator running on each of those data center environments. In the demo that I began with, there was one orchestrator sitting on our private cloud powered by OpenStack. The orchestrator is what takes care of the in-cloud infrastructure provisioning, infrastructure configuration, deploying the application, and any ongoing application management activities like implementing auto-scaling. This is really the cool part in Clicker. This is the key to our technology. The manager and the orchestrator speak the same language. So there's an abstraction layer. There's an abstract API that the manager works with. But depending on the cloud, the orchestrator calls into the cloud-specific southbound interfaces. So for the same application model, if it's being deployed on Amazon, the Amazon orchestrator will take care of calling into the Amazon APIs, EC2, EBS, setting up security groups to implement network ACLs, so forth and so on. But if it's an OpenStack orchestrator, our OpenStack orchestrator will take the same application profile and deploy the application on OpenStack using OpenStack APIs, Nova, Neutron, Cinder, etc. So you get complete, true cloud independence, and you can run an application workload on any cloud environment. If you start to run an application on one cloud, say a public cloud like Amazon, and later want to move the application to a different cloud, the application profile is already modeled inside Clicker. So we have all the data, all the metadata around the application. All we do behind the scenes is shut down the application on the current cloud, take a data backup. There are several hooks where you can provide your own custom backup scripts that might be specific to your application. We move the data to a central repository, and then on the target cloud, taking that application profile, we restore the entire application along with the data backup that was taken on the private cloud, on the original cloud. And this is what you will see in the demo. So this is truly what's at the heart of the system, the manager and the orchestrator. Some of our customers, some of our users start very simple. They will start with a single manager, a single orchestrator to manage one cloud environment. And over time, as they expand, they would add more orchestrators under management. So the use case that we focused on today was the application migration and onboarding use case. Clicker gets used for a variety of other scenarios as well. A lot of information around these are available on our website at clicker.com, and also very deep technical documentation around them. So one very common scenario with Clicker is not just being able to migrate an existing running application from one cloud to the other, but doing very commonly cross-cloud DevOps. So the idea here is you can use our model-based approach to create a model on an application profile. You can use that model during the development phase to run it on a public cloud and test out your application. And later on, when the application is ready to go live, you can release it to the ops team. The ops team can take the same profile and run the application on a private cloud. You can automate the entire process and get true end-to-end, automated, efficient, collaborative CI/CD. We also work with IT departments that like to use Clicker as a central IT as a service platform to provide governance and control, basically a single pane of glass to manage multiple tenants, multiple users, and multiple applications. IT can set up different service items, different application profiles, different clouds, set up capacity plans with optional chargeback and showback, while end users within the organization get the same simple self-service provisioning capabilities that they get directly on a public cloud like Amazon. Users can come in, start rapidly building out applications, and deploy them on cloud environments. So let's dive into a little bit more detail. I think we covered the demo scenario, and While all of this is happening, let me dive into a little bit more detail here on the UI itself. So let me start with our application profiles. So think of these as templates or blueprints where the user comes in, models their application inside Clickr. We have a variety of templates ranging from big data, Hadoop, high performance computing, batch computing, cluster computing, etc. There are some prepackaged templates for common stacks like Java, .NET, Ruby on Rails, etc. But the most common starting point for most of our users is our N-tier execution topology builder. So this is the graphical designer that I was describing. And inside this graphical designer, the left-hand side is the service palette, which has a variety of services available out of the box, ranging from load balancers, app servers, databases, NoSQL databases, etc. So whenever you're building out an application, this is where you come. You start dragging and dropping the components that make up your application. So let's say I have an Nginx load balancer. I have a Tomcat app server, certain databases. These could be a really important point. These could be VM-based components. So when you look at the MySQL or the Oracle DB here, these are components that are going to get installed on a virtual machine on the cloud that you select. But these don't have to be all IaaS-based components. You can also make selections that are specific to a particular cloud, like PaaS services. As an example, you can choose RDS MySQL, or you can choose a generic MySQL database as well. And then once you drag and drop the components, as I mentioned, you can interconnect them. And then on the right-hand side, provide more information about the application. So for each tier, you can select the base image that it needs to come up on. For particular tiers, you can also provide app-specific data. So for example, here in the Tomcat, if you want to run this as a cluster, you can provide the cluster size information. You can also point to any application packages. Your Tomcat Tomcat-based application would need some data, would need a WAR file, so you can select a storage repository, and on that storage repository, point to your WAR file location. And then there are advanced options where you can plug in any custom application-specific pre-start, post-start, pre-stop, post-op scripts. And then there are options around parameters, hardware requirements, advanced options around migration and upgrade. So as you can see, a very fairly simple way to create application models. And these can get as complicated as you like. You can drag and drop containers. You can create even composite topologies where part of your application is dependent on another deployment that's already been created, and address real-world, complicated, enterprise-grade application scenarios. And once you do that, your applications are available in this central catalog as it's loading up. And from here, you can take a variety of actions on your applications, like deploy them on a particular cloud, schedule them to deploy later, benchmark, or even the ability to publish these applications to a marketplace. So let's go and check how our migration is going. And these are the set of deployed applications that we have. This is where we had originally come in our demo and kicked off the migration. So as you can see, this AWS Confluence, which was our original deployment, has been automatically stopped meanwhile. This is not running anymore. And this is the demo that I had started. And this is currently deployed. So let's dive in and see how that looks. So this has been moved to the OpenStack environment available to Clickr thanks to Cisco. And on this environment, we have a two-tier application, the Confluence application that was migrated. The user is able to see all the information about the application. So you see your Tomcat tier, all the steps that Clickr Cloud Center took in order to bring up the application tier up. You can review all these activities. Optionally, if you want, you can even directly from the browser SSH or VNC into those virtual machines. Now let's go ahead and access this application. So let's access this Confluence link. Let's log in here. And as you can see, we have Cisco Live, the space that we had added in the Confluence application on the original cloud. The entire application has been migrated to OpenStack along with data in a single click. And so behind the scenes, it was the same common application profile that now got reused on OpenStack, and then we took care of the data. We took the data back up on Amazon, moved it over to OpenStack, and then brought up the entire application all in a single click. So that's the demo that we wanted to show you. There's a lot more inside Clicker around things like governance, ability to manage multiple users, multiple tenants, set plans around quota, usage, implement chargeback, showback, so forth and so on. A lot of fun features. So we'd love to hear from you, and please do visit our website, www.clicker.com. There's a lot more documentation, a lot more information available on how you can start using cloud very easily for your applications today. And we'd welcome any questions that you have. Any questions? Thank you, everyone. Thank you.